So firstly, just to clarify something, x is not equal to 6 in this equation, because minus 2 to the power of 6 is minus 2 times 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 minus 2, which is plus 64, and minus 4 cubed is minus 4 times minus 4 times minus 4, which is minus 64. So we're in the realm of complex solutions. So let's just have a quick look at an argon diagram here. Very quick look. There's the reals, there's the imaginary. The point minus 1 here in polar form, because that is pi, we can write minus 1 as e to the I pi. Therefore, minus 2 is 2 e to the I pi, which is 2 times minus 1, and minus 4 likewise is 4 e to the I pi. So we can rewrite minus 2 to the power of x equals minus 4 cubed. We can rewrite that as 2e to the I pi to the power of x equals 4e to the I pi to the power of 3, which equals 64e to the 3I pi. Okay, so basically what we do now is we take logs. So we have x log 2e to the I pi equals log of 64e to the 3I pi, and therefore we have that x equals log of 64e to the 3I pi over log of 2e to the I pi, and expanding that gives us x equals log 64 add log e to the 3I pi over log 2 add log e to the I pi, and log of e to the 3I pi is just equal to 3I pi, and log of e to the I pi is equal to I pi, and log of 64, well 64 is 2 to the power of 6, so we can rewrite that as x equals 6 log 2 add 3I pi over log 2 add I pi, and in actual fact that is the answer to our question, x equals 6 log 2 add 3I pi over log 2 add I pi. In actual fact, that's not the only solution. There are an infinite number of solutions. Just going back to our argon diagram, clearly minus 1 is equal to e to the I pi, but it's also equal to e to the 3I pi, and it's also equal to e to the 5I pi. So in actual fact, the general solution to our exponential equation here is x equals 6 log 2 add 2n plus 1 I pi over log 2 add I pi, and that basically gives us all of the solutions. So basically what that is saying, therefore, is that minus 2 to the power of 6 log 2 add 2n plus 1 I pi over log 2 add I pi for n contained in the integers is equal to minus 64. So let's just continue with this for a second. Let us imagine that the question was this. This was the question on an exam paper. Evaluate minus 2 to this power. Well, of course, we know that the answer is minus 64, but we only know that because we've just done it the other way around. How would we do this if this was an exam paper? Okay, well, basically, first of all, whenever you see in complex numbers something along the lines of log something a add something I pi, you always want to at least think about rewriting the I pi as log of e to the I pi. Sometimes that's a good way to start where you intend to try and simplify this. Okay, so basically let's rewrite this as minus 2 to the power of 6 log 2 add log of e to the 3 pi I. That's basically just rewriting that as log of e to the 3 pi I over log 2 add log of e to the I pi. Okay, and basically we have log, well, first of all, let's get rid of that 6. So that would be log 2 to the 6, which is log 64. Okay, so now we log plus log gives us, we can simplify this to be equal to minus 2 to the power of log of 2 to the power of 6 times e to the 3 pi I over log of 2 times e to the I pi, so it's getting slightly easier. Now, as e to the I pi equals e to the 3i pi equals everything e to the 2n plus 1 I pi equals minus 1, we can simplify this to become equal to minus 2 to the power of log of 64 times minus 1, because this is minus 1 and this is minus 1 as well, over log of 2 times minus 1. So basically we have now simplified it to be equal to minus 2 to the power of log of minus 64 over log of minus 2. But we've still got to get this answer to be minus 64. Okay, so what we're going to do is we're going to use the change of log base. Using the change of log base rule, log to the base a of b is log to the base c of b over log to the base c of a. Well, here we have both log to the base c. Well, ln is log to the base e, and this is log to the base e. So basically, minus 64 is b and minus 2 is a. So we can rewrite this as minus 2 to the power of to the power of log to the base minus 2 of minus 64 using our change of base rules. Okay, now finally we can use another log rule, which is that x to the power of log to the base x of y just equals y for any x and y. And if you're not sure about that one, let's just take logs to the base x. Taking logs of this to the base x would give us log to the base x of y, log to the base x of x, which is clearly 1, equals log to the base x of y. So this is true for any x and y, and so therefore we have here minus 2 to the power of log to the base minus 2 of minus 64. So basically minus 2 in this is the x, which means that we can simplify all of this here to be simply minus 64. And therefore we have shown that this horrific thing here is equal to minus 64, which we proved the inverse of when we solved the exponential equation up here. You're very unlikely to get that second type of equation, but this one you certainly might get. So I hope you found this useful. If you have, please like this video and subscribe to the Gresti Academy YouTube channel. Thank you.